right. Welcome everyone. Sorry we're a little late. Daylight savings time apparently changed the start time to be an hour from now. So we're kind of calling an audible here and rolling with the punches. All right. So today we're going to be working with particles. It was a requested topic last session, so we'll go ahead and take some time today to understand particles, what they are, how to spawn them, how to work with them, and how to use them. And we'll begin with kind of talking about how they work in 3D space and like some of the ways you have to conceptually think about them when you're like planning out your idea of using particles. Then we will show an example in vanilla and using a vanilla particle that already exists to create the particle in the game in the world and like have it work on a custom item, let's say a glow stick or something. And then we will actually add our own custom particle to replace that vanilla particle. And people might be like, well, Tree, my intent here or my want is like I want to make a custom particle first. And it's like, well, coming into it with no knowledge or with little knowledge, if you've never done particles before, my response to that is usually, well, you want to make sure that what you have works, and it's best to use a vanilla example, like gas grenade or a flare, something along those lines, just so that you know your code works first. Then you can add your own particle. And the reason why you do it in this order is because if you were to add your own particle and then do the code to make it work, and then it doesn't work in game, you have no idea if it's your particle that's a problem or if it's the code that you wrote that's a problem. And that then gives frustration for a new modder because they come into the scripters channel and they say, hey, my code doesn't work. Why? And, it's hard to understand what's going on from my perspective trying to help. So usually it's best to start from an example that you know works. And we know that vanilla works because we can load the game up and play it. So into like a gas grenade or flare, which means particles have to work in some capacity. So if we copy those and use it, then we can also know that our code works as well. So that's kind of the reasoning. Now we're gonna open up Paint because there's some overhead or there's just some concepts we need to know about when we are dealing with particles, mainly because particles are just really meant to be like a single point in space, and that space is 3D space, so we're talking about X, Y, and Z, and there are different ways you can represent 3D space. We have and it shouldn't be too complicated, so don't think it's going to be kind of scary. So like from the game's perspective, it has a couple different spaces that you can think about. We have the world space, which is what you would consider to be the like box that you can walk within, like the actual world, right? And the terrain lives in here, and there are trees and stuff like that. And it's a big box. Like in DayZ, in Cherno, it's like what, 15 kilometers wide. So this is a big box that holds the world space, so we'll call it world. And so this is important to know because when you're talking about world space, just like in geometry, you learn that every, any space that's created has an axis. And in this case, we have an X, Y, and Z axis. And if you were to sort of chunk these up into 1 meter cubes, you would eventually have like the Y would have a number, and up here would be like 15,356 or something for a 15 kilometer map. And then if you were to go out in the X direction, you would also find that it's 15,365 or something along those lines. And then the Z direction going into it. And so the world space has its own grid system. So we don't have to like get scared by the fact that we have multiple different spaces, because we know that if we like use this grid system here, it's all organized. All right, so that's world space. But then there is the notion of an object in the world has its own local coordinate inside of it. And so let's say we have a player. Let's go and zoom in here. Let's say we have a player that's standing here. right? He's got a position in the world. He's got some X, some Y, some Z position, and that's world space, right? And we need to know that because as he's moving through the world, we need to be able to draw him moving from one spot to another, all right? Now, just like the world space has its own coordinate system, the player or objects themselves have their own local coordinate system, and it usually just derives from their origin. Depending on where that is, I believe for a player it's down at the bottom of their feet. Like 0, 0 is their feet. But I mean, most of the time we consider local space or whatever to originate at 0, 0, 0. That just makes things easy. All right. Okay. So the reason why this is important, okay, is because when we're talking about particles, okay, and we want to draw a particle in this like 3D space that we've built up here, there are a couple ways we can draw a particle. One way is like a tree, in the sense that, or a building, that they're static, they don't move. My particle is in a spot. Let's say I want to put it like, let's go ahead and draw a little house here. Let's say I have a building and I want to draw the particle on the front door, right? You open the door and it explodes. So they're inside of this world that is the map size large, 15 kilometers by 15, or 15 kilometers by 15 kilometers. This door has a specific place inside of that space. Let's just say it's at like 2,000, 1,000, 2,000 for its XYZ. Okay. When we're talking about static particles, like I'm putting a particle on a spot in the world and it doesn't have to move, heli crashes are a good example. The heli spawns, the particle of smoke is created and it never moves. The wind just moves the particles. And so in the world space, we just need to know that, hey, I'm going to create a particle at this position. Perfect. Easy, done. Now, what if I wanted to do it on like a grenade, or maybe on a player, whereas it's moving in the world? It's not necessarily always at this location. And so in the second way of drawing a particle, we need to be able to add it to an object's local space. Okay, and so in this case, since we have local space, and if we were to chunk things up into 1 meter cubes, right, a player would be about 1.7 meters tall. Maybe, sorry, 1.2-ish, 1.6-ish in the game. And so we maybe want to draw the particle at 1.510. It's like the z-axis is like forward or backward from my forward-facing position. So I don't really want the particle floating out in front of me or floating out behind me. I kind of want it originating from inside me. And so you can kind of see a difference here now in the values. Like first off, like world space, we're dealing with huge values between the map size, map width, and length. And when we're dealing with local space, we're usually dealing with much smaller values because our coordinate system is around a local space, which is usually smaller. It's a subset of the world space. Kind of like if you were like in real life, if you were to extend your arms out like an eagle and twirl in a circle, you would create a circle around you, and we could call that your personal local space. And that's just an easy way of knowing, or like conceptualizing, how you have your own coordinate system relative to the world around you, which is the planet, and then the planets themselves have their own coordinate system relative to the universe, and then potentially the universe has its own. But anyway, you're seeing how we're kind of simulating that here, and you don't need to know how this is working. We use matrix math to make it all work. And it's just addition, multiplication, and subtraction. And so the mechanics of how it works isn't really important. The only thing that's important to know is, where are you spawning your particles? Are they being spawned on a static place that don't move? Or are you spawning it on something that does move, like a player, a grenade, a flare? The two approaches are different. Okay, keeping that in mind, we're actually let's go ahead and spawn a particle. And the easiest way to spawn a particle, in my opinion, is to use a vanilla example. And since I've mentioned the heli crash a couple times, we're going to go ahead and search the base game files and look for the heli crash and see how they do it. Heli crash class. Oh no, did they move things around a bit? Am I gonna have to maybe I'll get rid of the strict class in front of it. Heli. Well, here's the sound. Okay, here we go. Crash set, crash base. So I personally knew that HeliCrash extends from Crashbase, but again, I wanted the video to show how I take an idea of like what I want to do and search through the base files to get to where I want. I used a lot of keywords and a little bit of intuition to sort of get my way there. So now with my search results, I see, oh, I have the wreck M18 crashed. I have the Santa sleigh, the UH-1Y. And then it looks like here's the XML editor to load in all this stuff from the gameplay. All right. So if we look at the HeliCrash, we'll see that it is abusing inheritance pretty heavily, which is a good thing. Because as lazy programmers, we want to do things once and only once. We do not want to have to reuse code. Just reading this here, we have a new class. It extends Crashbase. We have that open over here in this window. The constructor, that's this thing here, is basically saying if the game is not a dedicated server, this exclamation mark is what we refer to as a bang or a not. It inverses Boolean conditions. So if you have a true condition and you say not true, that means false. And if it's not false, that means it's true. So in this case, is dedicated server if it's not a dedicated server, which means client. Some particle, we're going to get instance, and we're going to play it on the object. Cool. And it looks like we give it some enum or integer that represents the particle that we want to spawn. Looks like this, we're passing the object. And then some vector. And if you'll notice, these values here, this x, y, and z are relatively small. We are in local space. All right. Now, this isn't particularly effective or helpful from a new person perspective because A, we don't know what particle EFX is, and we don't really know what smoking heli-wreck is. So let's kind of decompose what we're looking at here. The variable particle effects comes from the parent class Crashbase, because we're inheriting it or extending it. If I extend something, I'm basically taking it and then adding on to it. So I have all of the original. And so if I go back to the original here, this Crashbase, I'll notice that I have the same variable name. So basically we get this for free. And we are registering. So Vanilla likes to register sounds into a hash map, which you don't really need to know what a hash map is, but it's a relatively safe way of making strings into integers and making them unique. Because sending strings are a bit heavier on the wire than integers, just the way they're stored and represented in like binary and stuff. So keep continuing on. CE create is central economy. So since these are usually handled by the XML, they have to be sort of loaded and handled by when the central economy actually spawns the events into the world. We have a request sound event function here, which if we look into what it's doing, it's basically packaging up a parameter containing a Boolean, a vector, and an integer. Boolean true, I know that just means play the sound. The position to play the sound, and the sound set, that hash. So the integer representing the string that is our sound. And we're just doing an RPC. And so in our last video, we covered what RPCs were and how to do it. And so this should kind of feel a little bit familiar, maybe not intuitive, but at least not the first time you've seen an RPC. So basically the server is telling clients like, hey, the heli spawned, and I know that this HeliCrash thing, this RPC makes the sound. And so whenever you hear the sound for a HeliCrash, this piece of code just ran. Get sound set. This is a helper function to actually get the sound. really useful for modding or overriding, because if it's not hard coded, I can mod this sound and I can now make heli crashes sound however I want, which you will see Santa's sleigh overrides the sound set with the sledge crash, which is, I think, the neighing of animals. I've never seen it in game. So EE init is what happens when this entity event is initialized. So in this case, it doesn't do anything. We have some developer tools here to test the sound, but this is just a pass-through function. You can ignore it. EE delete. What do we do when we delete this entity? And now here's an important thing. When we're dealing with particles, we have to clean up after ourselves, because particles are like a new thing on an object. And if we just delete the object, that particle, the reference to it, or the thing is still out there in the world. We haven't cleaned it up. We've kind of just like thrown trash on the ground and littered. And that's not very good, because if you do that a lot, you can really corrupt the heap and cause memory leaks in the game. And so if you'll notice, again, we say if the game is not a client, if there is a particle, stop the particle. And stopping a particle will destroy it, and it'll clean itself up for you. So this is a really big, important step when making a particle. And if you notice, Crashbase kind of abstracts that out for us, so we don't have to think about it. We just need to create the particle, as you can see here in the rec. So let's go ahead and kind of do this all together. And one thing I'll point out is that when we talk about a crash or a Crashbase, you'll notice that it's using an RPC. And I'm going to show you an example of a flare or a chemlight, which doesn't do that. And there's a reason, because when you're talking about a heli crash, the intent of the heli crash is to let everyone nearby know that it has happened. And so that could be a kilometer wide, it could be more than a kilometer wide. Whereas when things that don't need to be heard over a wide distance, like maybe the crack of a chemlight or a flare's particles, you can net sync that stuff. And so let's go ahead and look at that. Let's just look at a chemlight first. Chemlight. Color base. All right, so you would really think that chemlights are kind of simple items, but as you can see here, there's quite a bit of stuff going on. Ooh, this is new. Okay, so we get to learn something. Okay, looks like chemlights are actually a point light. That's kind of cool. Oh, nice. Okay, well, we'll cover this in a different setup, but that's really cool because point lights are very similar to the post-processing effect system, which are really useful for state machines and making cool light effects. Alrighty, so we'll reserve that for later. Let's go look at a flare. That's exciting. I've been in this engine for over 4 years now, and I'm always seeing new stuff. It's great. Oh, it's road flare. Okay, cool. Looks like the road flare is also a light, but we have this road flare is a really good example because it has several converging systems all in one. It has particles, it has sounds, it has a state machine, it has different textures that it's swapping out. Like this thing basically, oh, it has a noise parameter for zombies as well. It basically has a little bit of everything. Ooh, timer. Yeah, a little bit of everything that modding has to offer in one like discrete package. And so I always say I always recommend road flares for people to look at because this is a good showcase of what you can do. All right, and let's look at particle here. We have several particles. It looks like they've split out particles stages into the initial particle, the main particle, the final particle, and just smoke. And so if you've ever used a road flare, you know that when you strike it, it has that sort of sparking effect, and then goes into the bright light that kind of wiggles a bit, and then when it's final finished, the fire kind of changes to be reddish or less intense, and then lastly it's just a little bit of smoke petering out. So here's how they kind of handle that state machine. So if I come down here, I'm going to search on this variable for the particle fire. So it looks like they have all of the particle updating in this state machine handled in a single function, which is what, in my opinion, is a good way to do it, because you need something to sort of control and manage when a particle is showing and when it isn't. It's just good management, good UI management. All right. So we'll just look at this one a little bit in depth. Update all active particles if the game is the server, return. And so basically this is a client only function, and the reason why you want to do that is because the server should be the one that maintains the state. Like, am I burning? Have I started burning? Am I finished burning? Am I done? Like, do I have quantity? The client should really just be saying, should I display particle? Yes or no? And that way the client is kind of dumb in this case and can be really lightweight. Also, it's safe because you don't want to have the client dictate to the server what's going on. That introduces hacking and all other things. So if we look at this, if we're not a server, so if we are a client, look at the burning state of our flare. So if we're not burning, destroy all the particles. If it's the initial burn, destroy all particles and start one, basically. And in this case, we can take a particle and we can apply a property on it. In this case, a wiggle. We can change how much it wiggles a little bit, kind of add a little bit of randomness. If it's the main burn, add a different particle. And in this case, it's adding on top of the existing particle. Where if it's the final burn, we're going to destroy all particles and we're going to play a new one. And then if it's smoke only, we're going to again destroy all particles and play on the new one. And so what does destroy all particles do? Well, it just says it basically goes through all the particles that exist on the class, and it runs them through this function, and it says if you exist, stop. Boom. And it nulls it out. Basically exactly what needs to be done for getting rid of a particle. So that's how you would add a particle to an object. Easy peasy. Let's go ahead and do it on our own. Let's see if we can do it on our own. All right. How do we want to do this? Let's see, scripts. Let's go in for. We know this is going to be in for world. Let's make our own road flare, but it's going to be a little bit simpler. So entities. Let's make a new folder called item base. We're going to make a new file called my particle item.c. Class my particle item extends item base. We extend item base because we know we want our object to be an item, right? The difference between colon and extends is convention or preference. There's no difference. I'm gonna go ahead and just copy this. Actually, no, we're gonna write it out. Protected particle. My fancy particle. Okay. And one thing I like to do is, since I'm copying heavy of vanilla, we're gonna search on this variable and see kind of what's going on so that we can kind of emulate it. All right. So if we look here, this variable is being initialized to a particle in this capacity inside of a function here. So let's go ahead and kind of mimic that. Void update my fancy particle. Normally, I would probably just make this like void update visuals. That's usually my convention for syntax for updating a UI thing. But I'm using silly names just so that in the video, and if you're new to scripting or coding, you just trying to showcase that these names are kind of arbitrary. It's whatever you want them to be so that when you look at it, you know what it is. All right, so again, I'm going to kind of copy this, or we're going to copy the flow of this. So I don't want this function to run if it's on the server. So if get game dot is dedicated server. So if we are the server, we're going to just return out. We don't want anyone. We don't want the server to hit this. Boom, done. And looks like we have a state. We want to know if our particle is on or off, right? That's probably a good thing to know. So let's go ahead and say something like protected bool show my fancy particle. And I'm just going to initialize it to false. Mainly because I like my booleans to be false when they're created. So something I can do something like if show my fancy particle draw the particle. We're just gonna put some pseudocode here for now, and then I'm gonna finish out the else here. Else we're gonna destroy the particle. All right, and since that function doesn't exist, we're gonna go ahead and create it real quick to just stub it out. All right. So we have compilable code. That's what we want. We don't really want to create functions that don't exist, because if we get away from a compilable state, it's harder to find where the issue is. So it's always good to kind of mock and stub things out a bit. Okay, so let's go back to if we are showing the fancy particle. We want to check if there are any particles that exist. Well, really, we want to. So we could basically say, if you have a particle, don't do anything. If you don't have a particle, do something. And so, in my opinion, it's usually better to just say, if you don't exist, create yourself. That way, you don't have to worry about other cases. So in this case, that's exactly what vanilla did. If not my fancy particle. So basically, if this thing doesn't exist, so this kind of shorthand for doing that. Then I'm going to say create yourself. So my fancy particle equals particle manager. And we'll dive into what the particle manager here is in a second. It's kind of magic at this point. Hit instance. Sorry, my hands are really cold, so it's hard to type. Play on object. Okay, and so if we look at what play on object is asking for, it wants a particle ID, it wants a parent object, it wants some local position, it wants some local orientation. That's just the rotation on a 3D axis, so up, down, left, right, rolling, left, right. And then, should we force the world to rotate? In this case, the particle that we're going to use, we're just going to use the... Let's make a small smoke. So we're going to use this smoke. All right, and they define it above, which comes from this particle list. And so vanilla has like this massive particle list that you can choose from. And actually, let's go ahead and let's actually get a fancy particle instead of some stupid smoke. Easter egg. If you've never seen the Easter egg, it's pretty fun. Okay, so we'll use the Easter egg particle. And then we need a parent object, in which case the parent object is my particle item. So we'll go ahead and say it's this thing, this object. This is always kind of a hard thing to communicate to new devs or new coders just because it's a contextual thing. If I were to create 10 new particles, I would have 10 individual thises, one for each thing. So, right, you want a particle for each. So an easy way to reference, my own class, my own instance of a class is the this keyword. Okay. And so then we need a position, right? In this case, we're just going to use 0, 0, 0. Middle of the object. All right. Let's go ahead and set a little wiggle on things. And actually, let's go ahead and look at some of these other properties that you can set on a particle. Because wiggle is just the particles like moving around. Like if you look at a smoke grenade, you'll notice that it kind of moves a little bit, and that's the wiggle. Let's see, class particle. What do we got? Sorry, I'm just scrolling through this really quickly. Okay, so here we have the set wiggle, stop wiggle, randomize orientation. Okay, that's not what I wanted. We're gonna go, like, it's very easy to scale particles and to change them. So a good example is like in my Infinity Gauntlet, I love the fact that I can make the size and the lifetime, as well as like the velocity of the particles moving outwards. You can change all that. And so here we're gonna go ahead and change. We're gonna increase the size by quite a bit, and we're gonna change the lifetime. Okay, and I'm just gonna copy and paste those. And let's see if we can just show you what other different type of emitter params are. So you have cone angle, offset, velocity, velocity random, angular velocity, size, stretch, random angle, random rotation, air resistance random, gravity scale random, birth rate random, and that's like how many particles do you spawn in a second. The lifetime, how long does it live? Animations, random frame, the effector's time total, should it be repeated, the current time, total active particles, sorting, wind, and spring. I guess those are for other stuff. I haven't really used those, but you can see that you have a lot of different ways to modify a particle. And for now, we're using existing particles that we kind of know of, which are like volumetric. And what I mean by that is if you were to throw down a smoke grenade, it creates that type of volume feel, or smoke kind of creates that filling space feel. But in reality, a particle can be a flat, like smiley face. And that's what we're going to try and kind of do later when we make our own custom particle, is kind of showcase this notion of you can change a particle to whatever you want. And you shouldn't just think of a particle as a 3D point in space. It's really a 3D texture in space that can be modified at will. And so another way to think of it is the clutter that kind of flies around you when you're in the game, that's a particle. And you could make things like that, and you could technically create a visual effect or a drag effect where those get larger and smaller, or they breathe, or they swirl around you. Technically, they could just face you as they're rotating around you, just because you have this rotation angle
and velocity type parameters that you can change at will because it's a state machine. And so very, very useful. All right, I'll get off my soapbox there. Let's go ahead and set the reference there. We've set the wiggle to 10. The param for the size of our particle is going to be 1.8 to 2.5 times larger than is normal. And the lifetime is going to be 5 to 13. Just some random value. This is just a way to get things not so homogeneous. Okay. Actually set the right variable. And now let's go ahead and fill out the destroy particle. Let's go back to the road flare. So this is kind of a little overkill, I feel. We could do something like if underscore my fancy particle. So if the particle exists, my fancy particle dot stop. Now, here's the thing that I'm not sure if us modders need to do. Like, them nulling it out here is a question. Because I would assume... Let's look at particle. What does stop do? It stops particle. It sends out an event, gets the parent. Of the following, you might get an error when a particle parent is despawned client side. Okay. So under the hood, it looks like they set the particle manager to just use the add child, which is the way it should be done. And I was going to show the add child way, but it looks like it does it on its own, so we don't have to, which is nice. They've just removed the whole playing in world stuff. Okay. We'll go ahead and just do the same thing. My fancy particle dot set wiggle 0, 0. And then we'll just say my fancy particles equal null. No big deal. Because we just make a new one up here anyway. I think that's it. That should be it, right? Like, it's not a difficult thing. Destroyed it, we've created it, we've defined it. All right, let's go ahead and make our sample item so that we can spawn something in. Do I have any actual? No, I don't. All right, we'll just go ahead and class CFG vehicles hickles. We'll just copy the chemlite. We'll inherit from a chemlite. Cool. This should work in a sense that I should be able to just rip the chemlite config into my own item and then define it as my own item in script without it being a chemlite. Oh, we need a way to actually We need a way to actually call this function. I'm dumb. Duh. All right, we're not done yet. All right, so where does update active particles get called? When the work starts. Okay, so yeah, road flare is like a radio. You can turn it on and off. It has energy, so it will work for a certain amount of time. Let's go ahead and do this instead. Let's make it a road flare. Sorry, I didn't have the chat open on a mistake. Oh yeah, the rain. So the rain is just a particle, and let me open Workbench here in a second. We can look through some of the particles and like what they are. Ah, fingers are so cold right now. By mins, it's hard to type with mins. Okay, so since we're road flare, we have the on work start now, which means we're just gonna go ahead and hijack into that event. So basically, there's an action that you get. Action light item on fire. Action turn on while in hands. This function will look into the object and see if it has an energy manager, and it'll let you turn the thing on in your hands. So I know there is on work start. Yeah. We want that one. So basically when we start this thing, we're gonna call update visuals. This will only run once. Okay. So just thinking about this, my item base, we have a particle. We're not showing it first. Let's go ahead and just it's true. We're just gonna set that Boolean to be true. OnWork start runs on both server and client, so we don't have to sync anything. Which means the first time we turn this on, it's gonna kick out when it's the server, and basically, yes, we can show our fancy particle. The particle won't exist at the very beginning, so we'll create it, set a bunch of stuff on it, and then continue on. And then let's go ahead and say OnWork stop. Basically, once the road flares out, we should do the opposite. Turn off the Boolean again, basically turn off the particle. We'll go ahead and call our supers here. Okay, so we can turn the thing on. It should run, update its particle, and then after some time, it should stop. And actually, let's go ahead and make it so that it doesn't last very long. Class road flare. We're going to copy what we've got from road flare. The energy manager is what determines how long it runs. Let's spawn it in 100. It uses 10 or 1 per second. We update every 10 seconds, so we can assume it's 10 per second. Or sorry, 1 per second. Sorry, this will run for 100 seconds. And then convert energy to quantity. Let's go ahead and turn. This, I think this property will reduce the quantity as it's working. All right, so I think we have everything to actually test. So let's go ahead and like test it. All right. Oh, duh. I'm missing inheritance. Some of the it's yelling at me. It's saying I need the required add-ons, but like, yeah, you're not wrong. Not wrong. All right, we have our batch files. Let's go ahead and started the client up too early. Let's do the server. Seems to be good. Oh, I hope I have admin tools. I might have to load up a different map. They don't have admin tools on this. Yeah, I don't have admin tools. All right, well, we'll just pop this into a different server that I have. Not a problem. Nice. Okay, these have it. Cool. I guess while that's loading up, I wonder, snow. What happens if I just type in snow? Oh, of course, I get a ton of crap from these mods. Oh, actually, I wonder if I go into the particle list. If I find anything snow in here, snow step, snow vehicle, tree fall, bush falling.
Sakal Forest. A lot of step particles. Let's see, my particled items right here in the list. So let's go and drop a few. All right, I know it's my item and not the row flare because of the name. And if I do switch on, what do we got? Oh my gosh, our item, our particle. See that? It worked. Crazy, huh? It just goes to show you how kind of trivial, or I don't want to say trivial, but simple particles kind of are. Really, it's just a Boolean on the server that says yes, no, should you draw me? And the client will change itself based on that yes, no. And you might ask yourself, well, why didn't it keep going? Well, that's the first thing wasn't to create a looping particle. You can create a looping particle, but that is just something to modify the code. So we might get into that if we have time, but what I want to do is I want to get into the workbench and kind of show you how to change that particle now. Right? So so the whole point of this at the beginning is like, how do we know if our code works? Well, we know it works because I spawned my item in, I made a specific particle that wasn't part of the road flare. I spawned my item into the game, and then I verified that my particle actually was the one that spawned. So going from here to a custom particle should be simple. It should basically be changing this thing right here that I have highlighted. That's really the only change between this, what we have now, and a custom particle that we've created. Minus some like setting up the actual particle. You can see here we're registering it, but that's just overhead and copy paste. So let's get into actually how do we create our own particle then. We'll go and start the workbench. Is it a bit like EDDS? Yeah, basically. So all a particle is, and we'll show this off here in an example, is all a particle is a PNG. It's a texture. It's not some volumetric thing. It's a texture that's drawn on a plane. Well, it's a little more than that, but it's basically what you can kind of do. All right, so how do you get into a particle editor? Sorry, my dogs are playing in the background. They're having fun. You go into the editors inside of Workbench. So normally we've been in the script editor for a while. There's also the animation editor, which is if you want to get into animations. But there's the particle editor. Opens up this thing. So I have a particle already kind of looked at. But if you want to look at DayZ data or what's existing, like I don't know what this particle does, and if you don't want to load the game in to see, you can come into the particle editor, and in this case looks like Hunter Z has a particle here. Well, what does this look like? Oh, it's for a rainbow horse. That's cool. So like this is me looking at Hunter Z's particle, right? You can see a bunch of stuff. I don't really care about the stuff on the right. That's just the properties. He's making unicorns. That's funny. We should change this particle. Well, let's say pretty. Oh, here's our Easter egg. Let it loop. See?
An often one that people are probably pretty familiar of is the contaminated area. How do I go up and down? Oh, Q. Oh, Q and Z. I see. Okay. Interesting. That's not there. Let's go ahead and. Oh, nice. I can just preview them here. So boiling has a bunch of different stages because you can tell when it's done by just looking at it. This is one of the cooler parts of DayZ, in my opinion, is that a lot of the visuals are actually directly related to the state of the object. Oh, here's the Cupid bolt. Nice. That's a good one. And so you can make a particle loop. So that's what this one has done. Cupid hit is most likely a single one. But not all particles are looping. Here's your fires. Ovens, here's some fireworks. Geysers. Ooh. A particle loop for on-off items. So particles have their own properties, and one of those properties can be looping. But not all particles loop. And here you can see the smoke grenades. So you might have seen a mod recently that says better smokes. What they've done is they've removed the windness of a particle, and they've just scaled the particle up so that it's larger. People see that and they're like, oh my gosh, it's a crazy mod. It's like, not, I mean, from a mechanics perspective, yes, it's an awesome mod, and I agree. I did it on our own server as well, because vanilla smokes, in my opinion, don't have enough spread to be good enough as a singular item, and so people have to carry multiple, which causes frame rate lag. I'd rather have a single gas grenade that covers like maybe 4 times this area than 4 or 5 smokes that are all spawning particles. So you two can do the same thing by just scaling it up. Ooh, test. Spooky mist, toxic cloud. I'm half looking for rain. Look at that water jet. We can finally have waterfall. Or water up. Do we have rain? Rain. No, no rain. Water. Ooh, I like that. That's cool. Boat particle. That's good. That's a good particle. You can make that like a broken pipe. It's pretty good. Okay, cool. All right, let's make our own though. Let's see. No, let's make. Let's look at some of these. Do a point, a box, cone, sphere. We can have a shape size. We can have a cone. We can have a birth rate, offset angles. Looks like there's a default material we can use for this. Okay, that's right. Okay, it's coming back to me. So if I want my own particle, I need a emat and I need a texture. So let's go ahead and let's go ahead and use our wonderful example as our texture. Flood mode. No tolerance. And we're going to resize to, what's a good ratio? What is this default one? 256 by 256. All right, let's go ahead and resize our image to that. 256, 256. Oh, that's kind of lame. All right. Let's go ahead and do something like the lightning bolt. Lightning bolt. Zzz. That. We'll do something like this. Kapow. Okay, I'll keep this open on the other window. We'll go and minimize this. And if I remember right, in order to make a EDS, I just gotta click and drag this in, right? Like, it's been a minute. We're doing this live. We're just gonna go into my test mods. We'll go into, we'll make a new folder. Yeah, let's go and make a new folder. Particles. We'll just call this one particles because I want to make it nice and understandable. Refresh. Aha! I love it. Okay. Now we're going to go ahead and right click there. We're going to click new. E-material. And this is going to be something like my new particle material. Successfully registered. Where is it? Okay, you have to refresh. I believe I can just click and drag this in, right? Yeah, you just click and drag your PNGs in and it'll auto convert them. Refresh. Cool, so we got our kapow, we got our EDS. Let's go ahead and we're gonna leave. Where was the default one? Can you open in a new tab? So let's go ahead and compare, right? I'm just gonna flip between these two because I can't like have a new file or a new window over here, so it has this normal map and a height map thing here. Those are I don't see that here. But most likely the important thing here is the albedo map. This is basically what is the texture to draw. So we would click this and we are going to go to my test mod and we're going to go to kapow. And we're going to go ahead and alpha blend this, right? Yeah. Z right, Z bias. I don't think I need to change any of these down here. CCW, counterclockwise, opaque, sort bias is 0, cast shadow, yeah. No macro map, no SMDI. Wow, so it really looks like you can give like a real material file to this particle. So you have a lot of change. So you have macro map, so macro texture, normal map, give it actual like bumps and stuff. SMDI map, roughness and metal reflectivity. Fresnel, emissive. Wow, you can make your particles emissive. That's crazy. Okay. You don't remember all these steps when making your Ash and Rainbow Fuzz? Well, there's more steps because I'm not doing, this isn't a tutorial. This is really walking through how to navigate making your own thing so that when you have an idea for something that's not exactly a particle, you can do it. And it's not just copy paste. Okay. So I mean I feel like I have everything that I need here. Oh, matte super. Oh, okay. I need to change this. No wonder. It's not a material super, it's a particle. That's why. Aha. That looks a lot better. Cool. Okay, so let's go and save. If I go into my particle editor, is it there now? Can I actually like, or do I need to refresh this? I think I might have to close and reopen. Let's just check. Watch it crash on my new particle. I mean, it would be funny. Oh, I need to make a new one, right? New effect. Okay. And then the material I want to use is in my test spot here. What are these things up here? Move, rotate to world space, show hide bones, reset entity, change field of view, background color, box model, sphere model, PBR shape model, custom model. I don't need any of that. Okay. And look at that. Whoa. That's pretty cool. What if I want to make them smaller? You know, little babies. Right? Infinite ka-chow. So let's go ahead and see what happens when... Oh, I'm doing them at a cone angle. Max num is 10. Let's see, let's count these. Oh, actually, you can see the total number of particles up here. Birth rate is 2. Where's my lifetime? Let's do wind. so they float with the wind. Oh, lifetime right here. So what if I want these to last maybe 10 seconds? Watch. Watch the particles up here increase. Yeah, you see how that changed? You see how this changes how the particle emitter works? Because if I were to... Let's go ahead and leave the... I wish I could move around. Maybe I can't. Oh, that's just for the particle itself. Okay, never mind. But, okay. If I were to look up, you can see that I've only made the max number of particles I'm allowing to spawn in this manager is 10. And so you can see that as we hit our maximum, we have to wait for the ones up top to go away before we spawn the new ones at bottom. And you can see, like, when my view is small, it looks like it's delayed, but in reality, particles are flying off here. And so this is kind of like an optimization thing that you would do, whereas, like, what do you want your particle to do? If it's smoke, you want it to trail off eventually. Ideally, in this case, what we have is great because, well, maybe it's not great because we want a continuous trail of smoke, and in this case, it's not doing that. Whereas if it's like sparks coming off of electrical main, you kind of want some of this randomness. You might not want them moving as far, but that's just one of the things you play with as velocity. I mean, let's kick these up a notch in terms of speed. Right, or maybe you want them to hover a little bit when they're spawned and they stay nearby. This type of thing, you know? It all just depends on what you want. There's a lot of other things here, but you don't have to worry about that. Basically, this opens up so many different new possibilities. I've used this in the past to create glowing eyes for skeletons. Ideally, you just do a blue spray paint blob, you give 0 velocity, and just give them a wiggle so they don't move. You only spawn one of them, and they sit in the eye socket, and they just move and look menacing. And so we've kind of showcased how to take a particle, how to take really any image and turn it into a particle. Let's go ahead and save this file. We're going to save this effect into my test mod. Infinite Ciao. All right, let's get this into the game. Right, like how can we move this from workbench to game? And I'm going to take the Easter egg as an example because there's very few uses of them. And I'm going to see in vanilla where we actually register it. So vanilla looks like it has 2 areas. So one here. And then we register the particle inside the particle list. So let's go ahead and do that. Let's go and register our particle. This is going to be in 3 game particles, particle list, 3 game particles, new file, modded particle list.c. All right, and since I'm overriding this class, I'm just going to say modded class particle list. And I don't need to copy and paste all this stuff, but I will use one as an example. I copy pasted that, and I'm going to rename this to my fancy Ciao. And what's the relative? Why is this able to just use a baby name? Tracers made with this? Doesn't look like it. Oh, maybe. Gun muzzle, gun solo, gun particle. I think tracers are like emissives. That's how I would do it, at least. Where is that located? Okay, so what does register particle actually do? What's the magic going on here? Static register particle. Get path to particles. Oh, I think I might have to use this one. Get path to particles. Where is path to particles? Graphics underscore. Okay, I need to make sure I have my particle inside there. Do I have my particle in here? New folder, graphics, particles. Now I did just move everything, so. Oh yeah, Workbench will also throw this GUID, this global unique ID, and we shorten that to GUID. But you don't need that. In fact, you can get rid of it, and it'll most likely cause problems with your mod if you have it. I moved my file pathing around, which is why I'm going back into these files and changing it up, because if I don't, then it won't work in game. In fact, you can get rid of this meta file. You don't need it. Since you don't make, if you don't make mods for console, you can ignore that. Ignore all those meta files, actually. And I have no plans on making mods for a console. I mean, DayZ themselves has the game configured for console, and so you could make like content mods. I think, I don't know. I haven't looked into it. I know it's possible, but it's very limited. My test mod, graphics, particles, a kapow, part EDS. My test mod, graphics, particles, my new particle emat. My PNG is here. I don't technically need my PNG. I'm gonna go ahead and delete it. And then my EDS, which can't be viewed in here. Okay. So my file name is Infinite Kachow. So that's what I'm gonna need to set it there too. So this should just work magically. And the reason why is because the path to the particle is graphics particles. They've hard coded that here. And the nature of overriding and modding is that if I have things set up. Oh, actually, I might need to pull this out. Oh, no, I did. Awesome. Good job, tree. Okay, so this should just work. I should just be able to take my fancy kachow and come over here and replace Easter egg activate. So I'm going to go ahead and copy my old code and just paste it back as a comment, because if my change doesn't work, I want to be able to go back. And we're going to pack. Does that work? All right, we're packed. Let's go into the game and see if this works. Oh yeah, Nika had a question earlier in Modder's Discord about their workbench not working, and they were able to resolve it using gproj. And so gproj is a very special type of file format, and it's a way of organizing your folders inside of Workbench. And I'd say as a new person, you really don't need to know how to organize your folders on Workbench because you can always come back later and reorganize them. It's just an extra layer of understanding that you have to get through. And in my opinion, when you're like first starting how to mod and first using Workbench, anything extra outside of like using the tool is counterproductive in learning the tool. Like you'll just get frustrated because you're using something that's a very niche tool in advance and only a few people use, and so you won't get answers on it, essentially. Whereas if you stay close to vanilla and vanilla specific configurations, you have just more people that use that type of workflow and can answer your questions. Like, and this is me speaking from experience. When I first started modding, gproj is still kind of in the same state of documentation as it was. And so it's just, there's not much information about it. You know, I can't even answer questions on it because I don't use it. When I was new modder, I got frustrated and I stopped using Workbench. It was the reason why I didn't use Workbench until I learned, oh man, it's actually really easy. The difference here is gproj likes to separate out your files into different folders so that when you're in Workbench and you're browsing your content, you have source dir, which is DAISY files, and then you have your files as well, and you can browse them independently. I'm personally used to large code bases, and so I'm more familiar with Control F, find in all files, and search that way. Whereas new modders like to have their content split out and independent from other code, which makes it just easier to like read and think about. So it's a personal preference, I guess. I'm not against it anyway. gproj is good. It's a good format. It's just you're gonna have a little bit of wrestle to get it working. Okay, so let's see my particle item. Let's see if this works. No. All right. Well, something's broke. Let's look at no piston cup. Let's see. Oh, particle file not found. It couldn't find our particle. Correct path to this particle in script file particle list. So it's telling us exactly what the problem is. And I was half expecting this to happen. So I'm glad it did, because now I can showcase how do we actually like tell it to know where our file is. Let's go and clear out of this. Clear out of this. And that's what I thought. Okay, so there's an overload here, I guess. Oh, I'm dumb. Look, they even tell me how to do it right here. Look at this. This is what I get for not reading. All right, and this is again a very common example of a new modder coming in here, just kind of flying by the seat of their pants, not really being mindful of what's going on. So if you look here, it tells me exactly what I need to be doing. I need to mod class particle list. I've done that. And I make my modded particle, but I need to give it my modded folder. There we go. Cool. That should be all we need now. You can do override mods, I believe. You can do server-side mods as well. So anything you can handle server-side, you can basically do for console. As I've been thinking about it while we're compiling and loading. Which is quite a bit when you think about it. All right. And switch on. No, no, what's wrong? Oh. It's looking for the literal exact path. Okay. Wow. I would have half expected. See, in my opinion, this is where I, as a dev, like a Bohemia dev, would have enforced them, like a modder, to conform to my standards. I half expected mod folder to be concatenated to graphics particles and particle. This, personally, that's what I would do, just to make sure that all modders are following my standard, because I'm the dev. I know the best. All right, now it'll work here. We're giving it the full file path to our particle. It shouldn't break now. Keyword shouldn't. But again, this is kind of the normal troubleshooting and diagnosing process I usually go through whenever I'm building mods. Never do I get it right on the first time, and it's usually some amount of building code, expecting something, and then trying to figure out if it worked or not. This was a little bit more mature testing framework. I've been playing around with the test framework within DayZ. It's a bit difficult to wield. Not something you can automate, but normally when you're developing code, you write a test or some type of experiment that proves that your code is not working for the reason that you intend. So, like, if you give it 1 and 1 and it gives you the value 3, it's failing because you're outputting the value 3 specifically, versus like you give it 1 and 1 and then it gives you a syntax error. That's not what you're looking for. But if you can bound the way you create stuff to small, discrete experiments, you can really build complex things. Look at that. We're in the game. It's too big. Right. Oh my gosh. They're just going for... Oh, no, there you go. Oh. No! I love it. So this is what happens when you don't clean up your particles, right? And so, like, I just flippantly created particles. I didn't even, like, use a vanilla example. So I'm probably missing some things that, like, auto clean them up. So I'm just kind of showcase, like, why you can't just flippantly build things and expect them just to work. But at least we know that, you know, custom particles work. I think they're gone. Yeah, I think because I modified their lifespan in the script. And here we go. And they're off again, because it's, again, remember, in our particle that we actually created, it was looping. And so in game, it will loop as well, unless we turn off the looping. But you can see as well my item in my hand. Finally, the Oh, those should have been destroyed. Interesting. Because if you look at the item in my hand, the energy manager is now done. Those particles should have been cleaned up. Probably because I didn't set auto destroy. What if happens if we never clean them? Like, for example, I want to make a world, or at least half the world, a shy, ashy world. Would that ruin the world? So particles are client side, so it really depends on the strength of the client's computer. So if we look at like when we and this will be closing thoughts as we round out to noon my time. There's this notion in game development of trying to simulate the world, and some of us really like simulated world, some of us don't. You'll notice that when I flip through these views, things are drawn in like triangles. And from the computer's perspective and the graphics card's perspective, that's all it really sees. Is it sees triangles and it sees pixels, and it has RGBA, red, green, blue, alpha values, and XY coordinates for textures in 2D space, and it's trying to create this scene in front of us. And you'll notice as I'm walking in and out, they pop in and out. And the reason why they pop in and out is because from the game's perspective, there's a trade-off. If I was drawing 1 billion items in my view, 1 billion different points my graphics card had to iterate over, each one after the other, that would slow my computer down. And so that's a long-winded way of saying game engines have to be highly optimized for what they're doing. And particles are no exception. Actually, let's showcase that here. The more particles I have on my screen, the more things that have to be drawn. Plain and simple. And when we talk about programming, there are classifications of complexity, or generally understood time it takes to complete an algorithm. And so an algorithm can be, I have 100,000 things and I need to add 1 to each one of those things, which means I have to count 100,000 things and add 1 to each. There's no way around that. And so if I increase that 100,000 things to now 1 million things, we've increased the time it takes to do work. And when we want our engine to run 60 times a second, we want to update our frame, the image that we see 60 times a second, which means my graphics card, my CPU, everything within the pipeline between user input to what I see on the screen is 0.16 milliseconds. So that's a very short amount of time to do everything you see here, which is gather the state of everything, pipe it to the graphics card, show the particle, render it. So again, a long-winded way of saying, yes, it would impact performance. And the way to get around it is to do clever tricks like fog and view distance culling and technically not rendering anything behind me. So if I could pop my camera out and show it, technically everything behind my character, like all this stuff you see, and I turn around, like it gets de-rendered or gets like removed from my renderer. Like it's not actually drawing it. I only draw what's in front of me. And so it goes to show like it is faster for performance for me to manage what's showing and what isn't showing than just drawing everything. And so that's what the devs have to think about. They're always trying to balance this kind of stuff. Can we do a Particle 2 lesson next Saturday? I have a bunch of questions related to environment particles. More than what we did today. Yeah, I was trying to find the, like, you see these little things that are floating by? Like, those are just leaves. You can kind of see the little particles floating past my view. was trying to find out how to get that changed. It would have been nice to have those be little lightning bolts. But any other questions? I got time for probably about one more. Yeah, absolutely. You could make particles for rats and roaches. Absolutely. Small critters. Perfect. And the thing about that is it could be completely client side, because clutter like that is irrelevant between players, so I don't need to see the same clutter as your player. Because again, oh, I saw a spider, it ran away, you know? They could, no, I don't know if they are particles. They could be. Like, you can definitely make a particle that just floats along the ground. I mean, that shouldn't be difficult at all, given what we showed off today. Yeah, we do these tutorials every Saturday, and they're posted on YouTube. So I have we have the past ones in a playlist, but they're raw. I don't really edit them. I don't have time to edit them, so you have to deal with my ramblings and repetition. I do that on purpose because I expect the people that are watching this to not know how to script. For those that are veterans out there, you might get kind of annoyed with how often I repeat or cover some of these smaller, simpler topics, but that's just the way it is. Yeah, no problem. Thank you all for being here. I appreciate it. I do them if you weren't here anyway, but it helps to have an audience to speak to and answer questions. For sure, and make sure that the content's relevant. So just to wrap up for the video, what we did today was we reviewed vanilla particles. We looked how the particle system works. We looked at the Crashbase helicopter and how to sync sounds through RPC. We looked at the road flare on how to do particles through the energy manager. This is very similar to Set Sync Dirty, the NetSync type stuff, so it should be very familiar given the topics we talked about in the past two videos. We created our own item with our own particle and our own system for showing and hiding. We managed the particle to destroy it once it's done, and we eventually created our own particle and added it to the game. So I think we've covered quite a bit today, and a good amount of possible pitfalls that you can find along the way. So I hope you have a good weekend. I'll see you next week.